folks, welcome back. This is Joel, and in this video we'll touch upon probably the last concept in MPLS, which is the MPLS Traffic Engineering, right? Yeah, so this is the topology which we'll be using, but for now let's actually try to understand the MPLS Traffic Engineering, right? Awesome. So to do that, let me pick up right. Great. Yeah, so let's assume we have like probably a bunch of routers, right? Let's assume we have R1 over here, we have R2, and we have our R3, right? Now we say these are connected by various links, right? Let's say this is 5 Mbps, this is 10, right? And the other one being probably 10 again, right? So we have this kind of a setup. Let's probably add some loop backs just to understand. Maybe 1.0.0 here, this is going to be 2.0.0, and this is 3.0.0, right? Okay, so now if you imagine if a protocol like RIP was running, right? We have studied RIP before. We know that the metric here is only op count, right? So let's say the packet has to go from 1 to 2, right? The path which would have been picked would have been the 5 Mbps, right? This path, because it is closest, or it has the least amount of op count, right? But as in we went ahead, we got better protocols like EIGRP and OSPF, which would even consider probably the bandwidth and certain other metrics as well, right? So if I went with the EIGRP or OSPF, that the better path which would have been considered would have been probably the probably this path, right? Maybe via EIGRP or OSPF, such kind of protocols, right? Because bandwidth being a very important metric, and these links carrying 10 Mbps, this particular path would have been preferred, right? Which is good. But now let's assume for a minute, right? Let's assume for a minute my use case needs me that okay, before that let's also assume there is another loop back behind this. It is 11.0.0, right? So let's say there are two loop backs here, two loop back networks, and now let's assume we have a use case, right, where we want traffic going from 1.0.0 to where, to 2.0.0, right? Let's say this is an application traffic, right? And for this application traffic, let's say we want certain amount of bandwidth requirements. Let's put a number as 7 Mbps, right? We want 7 Mbps here. Okay, similarly we want from 11, right, going to 2 network again, but here we want say maybe 4 Mbps, right? So these are different applications, right, at the end of the day, and different applications have different requirements, right? So we have 1 and we have two requirements here. Now if you're running a basic IGP, right, let's say EIGP OSPF, then for the traffic to go right from from these two networks to R2, it would have taken the only single path, right, which is the best path, which is present in the routing table, right? For both these flows, right, the same path would have been chosen, which is this one. Okay, so nothing wrong with that. I mean, that's how the IGP or the protocols are designed to perform, and that's why they're working that way. But it's not very ideal, right? Because I'll be using this particular link and it'll be congesting this link, whereas we have a link here, right, which is with 5 Mbps idle, right? So how about we have a feature which will not just look at the best path which is obtained from the routing protocol, but also consider the bandwidth requirements of the applications or of the flows, right? So that is literally nothing but MPLS traffic engineering, right? Where we are no longer looking at just we are not looking at just the IGP, rather we are also considering the bandwidth. So in this case, the ideal way of fixing this would have been something like this, right? So probably for the 1 to 2 network it requires 7 Mbps, so I would probably use the below path, right? The path probably it would have been, for this it would have been R1 going to R3 and then going to R2, right, for this one. Whereas this requires just 4 Mbps, and you see that there is a link idle here. So for this one, ideally I could have used R1 to R2, right? So by doing this, we would have got a better throughput or a better output from the network, right? There won't be any idle links, right? So that is the inspiration, I would say, behind your MPLS traffic engineering, right? Great. So now the prerequisites. What are the prerequisites for running your MPLS TE? Is that you need to have an IGP, right? An IGP which supports MPLS TE. The only two which support are OSPF, and the other one is your ISIS, right? So this is one important consideration, right? You need to have your IGP, and it is OSPF or ISIS. The other one being, so this is the first one. The second one being what? You need to run a protocol called RSVP, right? RSVP is your resource reservation protocol, right? So these are the two consider. What is RSVP? Basically, it is in simple terms, if a flow takes a particular path, right, then this protocol will help to reserve the bandwidth on that path, right, so that no other traffic will kind of like no other traffic will use that. Like in this particular case, once it is decided that the traffic from 11 to 2 is going to use the path R1 to R2, right, and you require 5 Mbps, or in this case we require what, 4 Mbps, then that 4 Mbps will be reserved for this particular flow, right? So until this flow is there, this particular bandwidth will be used for this particular flow, and no other flow will be able to, or traffic will be able to use that bandwidth, right? So that is done by your RSVP protocol, right? So okay, so I think we have set up the basic context behind why we need MPLS TE, right? So the next thing is the other piece which I also want to touch up here is that there are two ways of doing it, right? So let me just get rid of this. Okay. Just clear this side as well. Yeah, so there are two ways of doing it, right? The first one is your static way of doing it, static tunnels, and the second one is your dynamic tunnels. What I mean by static is, in static we explicitly define the path the traffic will have to take, right? In this case, in this very specific example, we would have told, right, for one of the flow, please take the path R1, R3, R2, and for the other one, please take R1 to R2. So we would have explicitly defined the path over here, right? That's in static. Whereas in dynamic, what we do is we leverage the underlying IGP which is running, right? So we look at the IGP, we look at the best route in IGP, and we say, okay, if does this best route also comply with the bandwidth requirements of my flow, right? If it does comply, right, so here we use the IGP. If it does comply, then we use it. If it doesn't, then we try to find the next best path, which does comply with my requirements, and that particular path will be then updated on the routing table, right? Getting? Awesome. So I think we have set the context. Now we can go and just dive into a bit of hands-on so that we get more understanding about the whole paradigm, right? Great. So we have a very simple topology here, bunch of routers R1, R2, R3, R4. The IGP which I'm trying to use is OSPF, right? So like I said, the basic requirements is that we need to have what? We need to have my IGP and RSVP running, right? So these are two things, so which we will start with configuring that, right? So let's go with R1 to begin with. R1, let's do what? Let's do the basic IGP, and obviously you need to have the MPLS unicast routing as well. Let's do that, and we'll take it from there. Okay, so let's go to R1. Probably let me put it on my notepad, that'll be easier. So we go to interface, probably loopback 0, the address is 1.1.1, right, 255. Okay, probably gonna use another loopback as well, or well, not required. Okay, probably I'll go with the interface. So let's do one thing. This is gonna be easier if I do this. Let's just have it here. Let's take a snapshot of this, right, and let's just get rid of this and go here, and let's paste it here so that we have a reference to write down our configs, right? Great. So we have Ethernet 0/0 from R1, and what do we want there? We want IP address probably 192 dot I would go with 1 and 12.1. The basic interface configurations is what I'm doing. Let me also enable MPLS IP, do a no shut. Done with that, let's go to the next one, which is 0/1, and it's going to be what, between 1 and 4, so it is 14.1. We also need another one between 1 and 3, so that will be 13, so that will be 0/2. Okay, so that's good. And what else do we need? Yeah, so I think that's good. We don't want to use this for now. Let's see if we want later. Let's also put a routing protocol, like I said, OSPF, maybe 1, and you would need your router ID, right, and 1.1.1, and the network command is important. You would have 1.1.1 with let's use like exact address here, because we have used /25 area 0. What else? We would also probably need 192 dot 0.0.0, and maybe we'll have to change this to 255. I think we are good. And we also need to enable your MPLS LDP router ID loopback 0, right? Just take this and put it a little earlier, probably here. Okay, so that's your R1. Let me actually put this on R1 and see if everything is good, so that we can go and do the rest of them. This is, like I said, is the prerequisite. We are setting up the IGP and MPLS unicast routing in my core network here. Let's go to R1. Just set this up for a minute. Give me a minute. Okay. Yeah, so R1 probably is good to configure now. There you go. So that's R1 for you. R1 is good. Let's go and do R2. Change is going to be the IP address. So this is my R2. Still I have 3 interfaces. This is going to be .2. What else? 0/0 is going in for what? 12.2, and the next one is 23.2, and the next one is 24.2. That's good. This changes to 2, and that's the same thing here as well. Let's just go up. This is also is that. And what else? Okay, I might have made a mistake here. This is supposed to be 192. Okay, so let me do that. Okay, that's good. So this is good. We just take this, put it on R2. While it comes up, let's go and do R3. Okay, what else, so the 0 0 is going to be towards 23 dot 3, 0 slash 1 is 34 dot 3, and this is going to be 13 dot 3. Okay, this is good, this is good, the rest is good. This is R3. Awesome. We pick this up, Control C, and we're gonna paste it on R3. Let's clear the screen. And the last one is my R4. Change here would be R4. Gonna put it here, gonna put it here. This is good. The IPs would be different. For 0 0 it is 34.4, 0 1 it is 14.4, and 24.4. I think we should be good. Okay, that's your clear the screen a bit. Awesome. So while that comes up, yeah, so it's coming up. Good. We'll have to quickly check my OSPF neighbors and my LDP neighbors, right? Did the LDP come up? Show MPLS LDP neighbors. Okay, still not at come. So come up here. Yeah, so this guy seems to have 2 and 3. Same thing should be there on 4. Let's wait for a minute. It should come up. Whereas we can still, till then we can check the OSPF neighbors as it come up. So IP OSPF neighbors should work. There you go. 1 2 3, all of them have come up. Just need to wait for show MPLS LDP neighbors. Right, there you go. So we have 2 1 and 3, right? So all the neighbors have come up. Awesome. So we have this core setup, right? The core is set up with the MPLS and IGP, the basic IGP and MPLS. Now comes the RSVP, the second requirement. Like I said, right, the second requirement. The first one was setting up your IGP with MPLS. This is all right. The second one is RSVP, setting up RSVP, because this is the protocol which will help you to reserve the bandwidth you require on each of the links. Now what I mean by reservation is, you can see on my diagram here I have certain numbers put up, right? So here I want 512 kilobits of speed, right? So bandwidth 512 kilobits is what I want to reserve here. Here it will be 192 kilobits per second, right? So you can see these numbers. I want 512 on all these links, and on the center 2 links I want 192. So that's what I'm going to do now. I want to reserve that link, right? So to do that, what we do is, we are basically going to now enable RSVP, on the interfaces, of which are of need for us, right? I'll do that separately here. I'll probably put it as RSVP here, right? How do we do that? We enable first MPLS Traffic-Engineering. Traffic ENG should work. Traffic Engineering tunnels, right? Once you enable that, you go to the interfaces which are of need. For me, in this case, I want 00, 01, and 02 on all the 3 interfaces. So on all the 3 interfaces, first you go on 00, you enable again MPLS Traffic-Engineering, right, under that, and under that you are going to reserve the bandwidth. RSVP bandwidth. What is the bandwidth I want to reserve? Here it is. On 00 I want 512. You see this number? This is what I'm going to put here, 512, right? There you go. So now the other 2 links I'm going to reserve 0/1 and 0/2 is going to be 512 and 192 here. That's it. That is going to be our RSVP protocol. So just go to R1 and there you go. Done. It went in, right? Now similarly we'll have to do the same thing on where R2 as well, because you're going to reserve there as well, right? So on R2, is it different? This is good. 0 0 is 5 and 12, 0 1 is 5 and 12, and this is 0 2 is the same thing. So we're gonna pick this, we're gonna go to R2 and we're gonna put this. Let's see R3. Does it change on R3? On my R3 it is 512, 512, 192. Okay, looks good. Pick this and we go on R3. And the last one, R4. I think it's still the same. Let's go and put it here. So it's 512, you're right, 512, 512 and 192. So that's your R1, R2, R3 and R4. So let's go and put that on R4. So once we do this, our reservation protocol, or basically, sorry, I think I pasted something else. There we go. So we are done. The RSVP protocol is done. Our prerequisite is done. Now the next step is very interesting. The next step is, let's go and enable MPLS Traffic-Engineering for the IGP. So that will be a third step, right? Third step is you're gonna do MPLS TE, but for what? IGP. You're gonna enable it for IGP, which means in our case it's OSPF. So we have to do it for OSPF. So how do we do that? I'm gonna just put a tag as IGP for the guys to understand. Let's say MPLS TE IGP, right? And how do we do this? You go inside the router OSPF, which you have already configured, right? I mean, I could have done this all in one shot, but I wanted to show you the different stages of it, right? So that's why I'm doing it separately. Traffic engineering, just like how you would define a router ID for your MPLS, right? Similarly, you define a router ID here as well for traffic engineering, right? And because it is OSPF, you need to also put in an area. So you're gonna put the area. In this case, as you see, I'm using just area 0. There you go, that's done, right? So that's the command which would basically go in under everything, under your 2, right? It would okay, it's fine. It would go under 3 and it would also go under 4, right? So it would actually, you could try this. This is a very nice, easier way to send the same commands to every single guy. Send commands to active sessions. Did it go? Oh, okay, there was a mistake. This is supposed to be traffic. Okay, let's try again. Right. Okay, it went on 1. Okay, it did not go here. That's weird. Send all sessions and let's do this. Okay, so it went to R2. It went inside R4, R5. Sorry, not R5. I don't want it here. Okay, so it went inside R1, R2, R3, R4, right? We were able to send that. So we did that. What is the next step? Now comes the interesting part, right? So now this is where the differentiation happens, or what I mean by differentiation is, we talked about there are 2 ways of doing this, right? Let me just extend this a bit. I said there are 2 different ways of doing it, right? Static or dynamic, right? There are two ways. Right now we are going to be looking mainly at static to start with, right? So let's take a requirement and then build on top of this. So what is our requirement? Our requirement is that, let's assume that a router, say R1 and going to R4, right? So let's pick a different color here. So let's say R1 wants to go to where? 4.4.4.4, right? That's R4. And the traffic should use a particular path, right? Because it is static, so we are defining the path. What is the path we want it to take? Now in an IGP, it would have directly taken this path, right, the directly connected here, but let's say we want it to take a different path, right? So let's a different color. So let's say we want this guy to take this particular path, R1 to R2, and then it should go to R4 like this, right? This is what we want. So so this is the requirement, R1 to R4, but we want the path to be R1, R2 and R4, right? That's what we want. So how do we do this, right? Pretty simple. Go to my router, go to my R1, right, where it's called the source router, where the traffic is starting. Let's go to R1, and first we do is we create an explicit path, right? So we say IP explicit path. Give a name to the path. Let's say R1 to R4 enable, right? It's the name of the path and you're enabling it. What is the next address? Always so this is the path we have defined, right? R1, R2, R4. So we define the path using next address command, and we basically mention the next hop, right? So for R1 the next hop is 2, so it's 2.2.2, and again, sorry, here again you have the next address, which is 4.4.4, right? So that's the first step. The second command, or the second step which is needed here, is to define the tunnel, right? So you say interface tunnel 1, define a tunnel. Just go down a bit so that this is visible, right? So tunnel, inside tunnel, what do we do? So this is how it works, right? MPLS TE, whatever path we define here for static, we have to explicitly define a path. Now once we define the path, right, a virtual logical path will be created using the tunnel, right, which is going from R1 to R4, and that will be the path which will be used, right, to send the traffic, right? And the very important thing is this one. So I think I missed out that. We know that we want the traffic to go from R1 to R4, but what is the bandwidth requirement of this application, right? We want, say, 150. Let's put it as 150 is my bandwidth requirement, right? 150 kilobits per second. So it will make sure that 150 kilobits per second is reserved and utilized, right, for this particular flow once we do the whole configuration, right? And also the other point which I want to clarify here is that when I talk about this 150, right, the link speed or the link bandwidth could be something high. It could be 10 Mbps or something, right? It could be 10. But if you remember, we used the RSVP command earlier, right? And using the, okay, my pen is behaving weird. Yeah. So we used the RSVP command earlier, and we reserved 512 kilobits per second on this link, right? So this 150 will actually be taken out of that 512, right? So 512 has been reserved on this link for RSVP, for doing any kind of MPLS TE, right? And this 150 is basically picked out from that 512, right? So we'll look into that. So we'll create a tunnel here. We go into a tunnel. We will say the tunnel source is going to be picked up from the loopback. That's how you can do it. IP unnumbered loopback 0. The next one, I would say any tunnel should have a destination, and that's going to be your 4.4.4, right? Make sense? Tunnel mode is important. What is the tunnel mode? It's no longer GRE. By default it is GRE, but here it's a MPLS, it's a MPLS TE tunnel, right? So we explicitly define that. The next command is very interesting. MPLS tunnel MPLS Traffic-Engineering, right? That's pretty much common everywhere here. Traffic-Engineering, yeah, I think that's good. Yeah, Traffic-Engineering. But what is the command? Auto route announce. Auto route announce. So what this command does is, when if this path is available, right, R1, R2, R4, if this path is available with the required bandwidth, as per our requirements, then this particular tunnel will be put in the routing table so that the router can use it. So this command basically does that, right? The next thing is I can just pick this duplicate, and you can give a priority as well, right? So this priority will basically come in only when there are multiple tunnels fighting for the bandwidth. So I will talk about this priority later when we have multiple tunnels. For now, just assume that we can use that priority configuration to do that. The last part is tunnel MPLS use this bandwidth, right? The bandwidth which we want or our application want, right? This is not the actual bandwidth of the link, right? This is just use it for metric calculations, just for calculating or doing our decision making. That's it. This is not the actual. Don't get confused that, oh, we are gonna reduce the link speed to 150 kilobits per second. No, this is just used for metric, right? But we have to define here, this is what our application needs. And the last configuration would be explicitly telling the path. What is the path? Path option 1 and the explicit name which we have defined earlier, right? This is explicit, I think that's good. Explicit name, right? And from R1 to R4, this is what we have defined here, right? Sorry, I think I made a mistake. This one. So this is the name which we have here. We'll have to put it here, right? That's it. By doing this, we have actually configured a very basic MPLS TE tunnel. So let's go and test it. Let's pick this up and let's put it on my R1. I don't want this anymore, so let's clear the screen so that we get to see. Oh, okay, actually I really wanted to show you guys the show IP route before doing this, but it's fine. Now maybe I'll show it for the next example. So now if I do show IP route, you can see the tunnel has come up here, right? And if I do a show IP route, you can see to go to 4, it is no longer using a physical interface, rather it is using the tunnel interface, right? So this is the actual use of that auto route announce command, right? Because it found a tunnel, right, viable to carry our traffic. The routing table was updated with this particular tunnel, right? So that's basically what we did. We actually forced the router to now use, not only consider the best path from the IGP, but also the bandwidth requirements which we need, right? And yeah, what do I want to show you guys here? So let me also show you another interesting command, right? Show IP RSVP interface. To do this, here you can see on this interface, which is Ethernet 0/0, right? We have allocated 150 kilobits per second. That's what we actually did. So if you look at the use case we had, we wanted 150 kilobits per second from R1 to R4, right? So you see this particular interface on R1, which is Ethernet 0/0. See, we have 150 kilobits per second. The max is 512 kilobits per second. And what is this max? This was reserved by the RSVP protocol, which we configured earlier. We explicitly put 512, that is why it's 512, right? And out of that 512, we have used up, or we have allocated 150 for this particular tunnel which we created now, right? Awesome. What else? Another interesting point which I want to call out here is that from R1 to R2, we have reserved 150 kilobits per second right now, right? We have used up, or we have allocated 150 kilobits per second for this particular tunnel, which is good. But do you think from R2 to R1, right, do you think that 150 kilobits per second was allocated? Actually it is no. So if I show you this, if I run the same command on my R2, you will see on R2, the Ethernet 0/0, it's 0, nothing has been allocated. So allocation is always unidirectional, right? Which means from R1 to R2 we have allocated 150, but from R2 to R1, right, we still have 150 kilobits per second, right? It's always unidirectional, right? That's why on R2 you will see allocation happening only for Ethernet 0/2, which is the one which is going towards R4, right? So that was the whole tunnel going from R1 to R2 to R4. So this only in this one direction, right, we have allocated, whereas in the opposite direction we have not. right? So that's something which I wanted to call out as well. Okay, so that's actually, how you configure uh, the basic. So let's look at some other requirements as well, right? Let's look into another requirement here where give me a minute. A different use case now, um, or let's we did R1 to R4, right? Let me actually clear this up, looks a bit messy. Give me a minute. All right, just pick a snapshot from here, paste it somewhere down here. Okay, so what did we accomplish? We did the first one. One sec. Yep. So what did we do? We did the first one, which is basically R1 to 4.4.4.4, and what did we reserve? We reserved 150 for this particular path. Okay, so the next requirement is going to be from let's say we want to do R1 to R3, right? Let's do that. Let's do R1 to R3, that's 3.3, right? And how much do we want to reserve here? We'll probably say we want to reserve 300, right? So we want to reserve from R1 to R3, so which is R1 over here, and we want to go till R3, right? And the path we want to choose is probably R1, R4, and R3, right? So we want to go from here, and from here, right? That's what we're going to do. So again, the configuration would be on R1 itself, right? Let's just copy this, just paste it here, right? Go a bit top so that you can see. It's very quickly we could do this, right? So we go from R1 to R3. I believe that's what we want to do, R1 to R3. The next stop is obviously going to be 4.4.4, and then we are going to have the 3.3.3. So let's remove this and let's put this here, right? That's good. And a tunnel, let's create a different tunnel, tunnel 2, and loop back is good. The destination is 3.3.3, and traffic engineering, all of this is good. The rest, everything remains good. This changes to R3. That's it. So we have the second tunnel coming up now. Let's go to, but before that, my question is, from R1 to R3, do you think this tunnel will come up? Yes, because you see we have 512 right over here, and we have 512 here, right? And it's empty, it's not been used at all till now. So we have the whole 512, and since our 300 is less than 512, it is going to come up, right? Let's try. So we go to R1 again, right? So see, the tunnel has come up. Now if I actually do show IP route, you will see that to go to my R3, it's actually using the tunnel 2 which I just now created here, right? You can also see another interesting command here which I want to show is show MPLS Traffic-Engineering, probably tunnels, I guess. Yep. So here if you see, not the tunnel 1 which we created earlier, but if I yeah, so this tunnel 2, you can actually see the path, the explicit path which it is taking, right? So it's going to R4 and then going to R3, R1 to R4, then R3. So that's the exact path which we had defined, right? Let's continue. What is the next requirement? Let's say we want to go from say R4, we want to go from R4 to where? Say R2, which is 2.2.2.2, and how much bandwidth do you want to reserve here? 300 kilobits per second. Let's say go for 300, right? And how much, which path do we want to take? We want to take R4 to R1 to R2, right? we want to take this path, right? So give me a second. That, or maybe we could pick a different path, or should be fine. Let's see. I think it should be fine. Yeah. So yeah, let's do that. So we want to go from R4. So this would basically start from R4, right? So source is R4. So let's just copy this. I just wanted to remind you guys that yes, you might think that okay, we used 512 kilobits, but we used it from R1 towards R4. We did not use it from R4 to R1. So the tunnel will still come up, right? Because the tunnel allocation, the bandwidth allocation was happening unidirectional, right? That's something very, very important you need to remember, right? So we're gonna go down here, and the next path is clearly 1.1.1, and the other one is the 2.2.2. The tunnel, okay, that's good. The destination is 2.2.2, traffic engineering, all of this is good. And this is basically, okay, so it's actually going from what, 4 to 2. So we're gonna pick this, you're gonna put it here, right? So that is basically going up where? It's going up, and okay, my bad, the bandwidth which I needed here was 300. I hope I changed that in my earlier, okay, my bad, I think I should have changed this to 300. Okay, let me actually do that right away. So go to tunnel 2. This one was supposed to be 300. By mistake, I just retained the 151, right? Cool. So that's okay. Let's go to R4 now. Pick this one up. And this will basically go to R4. Clear the screen. There you go. See, the tunnel has come up. And we have the explicit path from R4 to R2 now, right? We have done the same. We have explicitly, defined the path which the traffic will take, right? We can actually do a trace to see if it is actually going that way. Trace to where? 2.2.2. Source it from probably 4.4.4, right? It should first go to where? It should go to R1 and then it should go to R2. Right? Give it a second, it should come up. Meanwhile, I just want to check if this tunnel is good. Show IP interface brief. Yep, the tunnel 2 is good, which is good. Okay. So yeah, this is what I was telling. See, it's going to R1 and then going to R2, exactly as our plan. Okay. What do we do next? Let's continue doing this because I wanted to show you guys the priority part, right? So let's do one more. Let's say we want to go from R2 to R1 now, right? And we want to reserve say 400 kilobits per second. So let's do another exercise. So we do, let's go back. So the next one which we want to do is R2 towards R1. 1.1.1, and how much we want to reserve? We want to reserve 400 in this case. You see, there is nothing which has started from R2, so I'm pretty sure we have this 400 gigs, the whole 512, right? The 400 gigs is available to me, which means I will be able to bring this tunnel up on my R2. So let's hope to do that. So let's go to R2. The next stop is clearly, what's the path we want to take? The path we want to take is R2 and R1, right? The direct path, right? So the next stop is going to be this. The destination is 1.1.1. Tunnel, probably the number is 1. This is good. This is 400. And the name is basically R2 to R1. That's what we want. Pick this up, paste here, and I think that's good. So we take this. And where do we put this on is my R2. So let's go to R2. Let's see if the tunnel comes up. Yes, the tunnel has come up, which means there was enough amount of bandwidth for the tunnel to come up, right? So yeah, so that's good. Now the last one which I want to do here is one more exercise on which one? Let's do it probably from R2 towards R4. And how much I want to reserve here is 200 kilobits per second. Right? 200 kilobits per second. And the path is basically going to be from R2, R1 and R4. Right, this one, R2, R1 and R4. But if you see here, we already used up 400 from here. Right? What is left is what? We just have like 112. We just have like 112 kilobits per second. But we literally want 200, for this link to be set up or for this tunnel to be set up now. So you will see that the tunnel might not come up now, right? Because that would basically go with the theory which I have been telling from that time. That is, the tunnel will come up only if the bandwidth requirements for that particular application are ready. So what we'll do is, let's go. Let's put the next stop as 4.4.4 because we are going from where? We are going from R2 to R4. And a tunnel, probably put a tunnel number, right? Loopback 0. This is going to be 4.4.4. All right. And traffic engineering, this is good. Let's put this as 200 and R2 to R4, right? Let's pick this one. Now when we put this on R2, I'm pretty sure that the tunnel will not come up. See, the tunnel is down because we really don't have the bandwidth which we need, right? Show IP, if I do show IP RSVP interface, you can see here on this particular interface, 0/0 interface, we have already used up 400, right? So we don't have another 200 to be used on this, right, on the 0/0. So that's why the tunnel did not come up, right? Now this is the time when I actually want to talk about that priority which I was telling you guys, right? So we have been using this particular command, right? We have been using the tunnel, the priority 4,4 is what we have been using, right? We have been writing priority 4 and 4 in all my commands, right? So what does it actually mean is that the first one actually stands for setup priority, right? Whereas the second one basically stands for the hold priority, right? So if two tunnels are coming up at the same time, right, then the one with the least priority will be the numbers, right? The one with the least priority, these numbers go from 0 to 7. The one with the least priority will be given importance. The one with the least the one with the least setup priority will be given preference if both the tunnels are coming up at the same time, right? If one tunnel is already up, which is in our case, right, we already have a tunnel going from R2 to R1, and we are trying to form one more tunnel from R2, R1 and R4, right? So in that case, what happens is the new tunnels setup priority will compete against the old tunnel's hold priority. Getting? Right? So for the new tunnel's setup priority is this one, and the old tunnel's setup priority will be the second number, right, which we have configured in the old tunnel. So these both will fight, and the one which wins basically gets to form the tunnel. Now in our case, you see what has happened is everywhere it is 4, right? So the old tunnel, when the numbers are equal, the old tunnel gets to stay, right? So that's how it works. So in my case now, what I can do is, let's change this priority on the new tunnel to a lower number. Let's change it to probably 3 and 3, right? And we'll see what will happen is that the new tunnel will get the more priority to come up, right? So let's go to tunnel 2 here, right? Let me go here to tunnel 2, and instead of running priority 4.4, what I'm going to do is I'm going to say 3 and 3. So when I do this, you can see here the new tunnel is now coming up. The tunnel 2 is coming up, whereas the old tunnel will actually gradually go down. It will take a bit of time, but then the old tunnel, right, the second tunnel will slowly go down, right? So always remember the priorities, right? The first one is your setup priority. Let me clear this a bit again. I think it's all confusing to see this. Right? So there are two priorities. One is your setup and the other one is your hold, right? So if both the tunnels are coming up at the same time, then setup priority will be used to make the decision on who stays or who gets the bandwidth and all of that. If one tunnel is already up, right, then what we'll do is we are going to use the new tunnels setup priority, right? This will be the new tunnel setup priority, will be fought or will be used to fight against the old tunnels, right? The tunnel which is already existing, right, will be used to fight against these both guys, and whoever wins will basically get to form the tunnel, right? So that was basically what I actually wanted to show you as part of the static. This was basically as part of your static tunnels, right? The next one we'll be looking into is the dynamic tunnel. So before that, let me just clear out, let me just go and remove all these tunnels which I have created here. Let me clear the screen. Right, so think tunnel 1, and I really don't want the other tunnel as well. Good. Okay, do the same thing. Probably there are two tunnels here as well. No tunnel on the first one. I don't want the second one. That's good. Let's go to the third one. Okay, there was no tunnel 1 on this. Probably there was tunnel 2. Okay, there was no tunnel at all. Which is good. Okay, there's nothing which is configured on R3. Cool. And on R4 as well, let me go and remove tunnel 1, probably tunnel 2, and let me just save up whatever I've done. Okay, so the next topic which we'll be looking is the dynamic tunnels. Start with the dynamic tunnels. Let me just clear this off because we don't want this anymore. Right, we take a fresh snap. Put it down here. Yeah, that's good. So unlike static tunnels, here we don't define the explicit path. All right, so that's the main difference between dynamic tunnels. So rather, dynamic tunnels, they basically work in conjunction with the routing protocols, right? So first, MPLS TE, it will check if the best path from the routing protocol meets the bandwidth requirements. If yes, that will be used. If not, the backup route will be chosen from the let's say LSA table, LSA database, which will meet the requirements for our application, right? So let's dive in, right? Let's start doing the same exercise which we were doing earlier, but we are doing slightly differently because we are doing dynamic now, right? And the first use case is that we have a source R1, and from R1 we want to go where 4.4.4.4. all right, and so this traffic should have how much amount of bandwidth do you want to reserve here? We want to reserve 150, right? So we want to make sure that the path which is going from R1 to R4, right, it has 150 kilobits per second available for it, right? But the difference here is that we are not going to define an explicit path. Rather, we are going to use the path which the routing protocol is going to give us, right? So let's go to R1. That's where we are going to do the configuration, right? So on R1, we're going to change this to say dynamic tunnels just to show the difference, right? What you do is you don't have to do explicit path, right? So you directly go jump into your tunnel, right? Tunnel say 1, I've removed my old tunnel, so this should work. And this is still going to be the same. Let's just copy this part, right? The tunnel source is same, the tunnel destination command also remains the same, just that we are going to change the destination here to 4.4.4 because we want to go from R1 to R4, right? Then what do we do next? This also remains the same. You enable the mode, right? Give me a second. Yeah, anyway, so we go and enable the traffic engineering, right? What do we do next? We still have to do this command as well, so I'm doing one by one, right? We still do the auto route announce because we want the newly created route, right, whichever route, optimal route which is being chosen to be put in my routing table. So I'm going to do that. Priority remains the same, right? And actually even the bandwidth remains the same, right? Even these two, both the commands remain the same, right? The bandwidth is 150, so we're going to retain it. Now the only changes in the last command where you are explicitly defining the path here, right? Rather here we don't do that, we use the keyword dynamic, right? By doing this now, my R1, which is over here, will reach out to R4, right, via a tunnel which might or might not be the best route from the from the routing table, right? So we can test that. So let's copy this. Let's go to my R1. Before going to R1, now I'll show you this. I want to show you what is the current state, right? So let's do show IP route. So if you do that, to go to R4, you see the route is through Ethernet 0/1. So it is using this one, right? This, let me draw it here. So it's actually using this particular path here, like this, right? This is the IGP path which it is using. Okay. Now we will actually get to see what path it will use once I enable the traffic engineering, in fact the dynamic traffic engineering. Okay, my bad, copied something wrong. There we go. The tunnel is gone, the tunnel is up. Great, right? Once the tunnel comes up, I could run something like show MPLS Traffic-Engineering. What else? Traffic engineering tunnels, probably, right? There you go. So this tunnel, now it is going to tell you what explicit path it is going to use. It's actually using the direct path, right? It is going directly to R4 from R1, right, from here to here. So in this case, actually the best route which was in the routing table ended up being the MPLS TE route as well, right? Because it had the bandwidth, right? Because you see here the bandwidth is 512, and what we needed was just 150 kilobits per second. So there was bandwidth, so that's why it chose this path, right? Let's continue our use cases. So let's do the second one where I'm interested in what? Say, my bad, right? For the second one, I want to go from our, actually, let me do, one sec, give me a second, my pen is stuck again. Great, okay, we are back. So second one, what I want to do is I want to go again from R1, but this time I want to go to R3, right? And what do I want to reserve? I want to reserve 150, or maybe let's go to 300, right? I want to reserve 300 kilobits per second, right? That's my use case. So again, I go to my R1, right? The command is going to be almost the same, right? Just pick this up. Probably I'm going to put a different number for the tunnel 2. The destination changes to 3.3.3. Traffic engineering, this is good, just this changes to 300. What else? The rest is good. Let's just pick this up and put it on our router, right? Before that, let's check what is the route being used. Right, it's actually using Ethernet 0/2, right, to get there. Or I could do this, right? To reach 3, it's actually going through R3 directly, right? Here you can see from R1 to reach R3 it is actually using this path, right? That's the um, Ethernet 0/2. Yeah, so that's the best path which it is actually using. The IGP itself is giving me that route, right? It is using this. That's what we found from the IGP table. Now let's see, after putting the tunnel, will it still use the same thing? I'm doing R1 to 3, right? Yep, that's good. Yeah, so okay, my bad. Right, so we're gonna copy this and paste it. Let's see if the tunnel comes up. Yes, the tunnel is up, right? Now we can run this one to see what changes has happened, right? Is it using my tunnel? Yes, it is using my tunnel, right? And I can do show MPLS Traffic-Engineering, right? Tunnels. So we should be interested in tunnel 2 because that's the tunnel which we created now, and you can see what path is it taking. It's going via this path, 192, it's going to R2 and then going to R3, right? So it is actually taking this path here. Why did it do that? Right, now you see the exact difference. Why did it do that is because, see, we needed 300 kilobits per second, but it could not take this best path because there was only 192, right? So it had to choose the next best path, right? So it chose this one. I mean, obviously even there was another path here as well, but out of these both, it ended up choosing this one over here, right? It ended up choosing this one, right? So I understand the difference. So this is the beauty of dynamic tunnels, right? It shows the path automatically, right? That's good. Now we'll do the next one. Let's do the same exercise on few more things, right, to understand more better. uh, okay, so we go to the third exercise, which is from R1, and let's say we go to 2.2.2, right? Let's keep our bandwidth to say 300, requirement to 300, right? So we are going from R1 to R2, right? And we want the bandwidth of 300, right? So let's see what path it's going to take. So again, we're going to do this on R1. Let's pick this up, probably call it as tunnel 3, right? Destination is going to be what? 2.2.2, right? The rest is good. It's 300 and the rest, everything is good. We're going to pick this up and let's see, to begin with, what is the do show IP route will tell me what is the current path being taken to go to 2. You can see it's taking the Ethernet 0/0, right? Which is this one, right? It is taking the direct path, right, as part of IGP. But you see now, after applying my tunnel, let's see what is happening. Right? Right? So now, yes, the tunnel has come up, but the difference would be MPLS Traffic-Engineering and tunnels, right? So now let's see the actual path which it is going to take. Not tunnel 2, we are interested in tunnel 3. Yep, this one. And you can see the huge or the long path here. It's first going to R4, then 3, and then 2, right? It's going first to 4, 3, and then 2. So this is the path which it is taking. Let me highlight that. So it's going from R4, 1 to 2, then 3, and then 4. I mean R1, 4, 3, and over here. This is the path it is taking, right? Why did it do that? Because you see, it could not take this direct path because the bandwidth was already used up in my previous tunnel, right? So it had to choose another one. So you're getting the drift of this, right? In dynamic tunnels, we don't have to explicitly define the actual path. Rather, it's going to kind of like figure it out on its own using the backup paths which are available from the routing protocols. Got it? Awesome. So what do we do next? There's one small part probably I'll do is I want to do fast reroute. For that I would need another topology. So let me pause it here.